Hi, I wanted to create an explanation for essential question number 2, version 7 from the summer of 2011. This is just the cash flow diagram that you should have seen on the sheet. And to get this problem work out, you got to notice that there's several linear gradient series here, and actually there's a bunch of hidden constant series sitting in the middle. Now the way I'm actually going to think about this is that I'm thinking about this chunk right here, all the way from time period up to time period 4 as being a linear gradient series. Then what I'm doing is I'm visualizing a constant series that's 10 high all the way across from time period 5 over the time period 13, and then sitting on top of this is a linear gradient series. And so there's 1, 2, 3 chunks that are sitting about right here. So let's deal with the first chunk of it, which is just a linear gradient. So we're going to look for P. Oops. This is going to be messy until I get myself a stylus. But what we're doing here is we've got something that goes up by 2 each time. So it's 2, looking for P, given that we know capital G, whatever the interest rate is. And what we've got to do is count the number of steps. So we have 1, 2, 3, 4, 5, plus 1 for the pot, so it should be a 6. And then deal with how we're supposed to time shift this thing. So it's 1 plus I. And if you sort it out right, you notice that the last time period where we see that value is time period 4. Well, if you put a minus 2 right there, 6 plus minus 2 is 4. And if you think about it, if you go minus 1, minus 2, that's essentially where the numerator dumps all the values in time period minus 2, and this just moves it back up to time period 0. So now let's go ahead and add in the constant series, which are basically all these 10s from time period 5 out to 13. So this is something which is 10 high, and we're looking for P, given that we know A. Here's the I, and the N is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we know we're going to have to time shift it. 1 plus I. Oh, that's gross. And since it's supposed to go out to time period 13, we know that if we go ahead and put a 4 right there, we should do it right. And if you think about it, the numerator takes all the value, dumps it right there on time period 4, and then what the denominator does, that 1 plus I to the 4th, it moves it all the way back to time period 0. Last thing to deal with is this linear gradient series that sits up top. And so that's something which is an increase by 1 each time. So 1, looking for P, given that we know G. Here's the I. The N is 1, 2, 3, 4, 5, 6, 7, plus 1 for the pot is 8. And then we have to time shift it. And if we do this one right, 13, and that should be, what, 5. So 8 and 5 is 13. 13 is the last time you see an element out of the linear gradient. And if you, oops, did I do this one right? 1, 2, 3, 4, 5, 6, 7, 8. And 8 and 5 is 13. It is right. I don't know what I'm thinking, but this is the relative time period 0. This is the relative time period 1. That's 2, so that's the first time you see a value. So that should work out. Anyway, so this is the factor notation of a decomposition of essential question number 2, version 7, during the summer of 2011.